Okay, so what we're going to look at now is in networks is scheduling problems. So we were looking at the networks and when we had an activity and then we had, previous activities, and we're setting up, what we were doing is setting up this scheduling network, and we had a look at them, and down here we had a look at it. So if you've looked at this activity C, this activity C must happen before E happens. That's because we know that, and that's why this little dummy, activity F, that's why there's a dummy thing happening. So that this concept and understanding that is going to come into play with this scheduling. So projects that involve multiple activities are usually completed against a time schedule. So we know that. So what happens is that they need all these jobs to be done for the production line or whatever's going on. So allocating to the time of activities in a project is called scheduling. So we're going to schedule and see things. So scheduling problems involve analysis to determine the minimum overall time it would take to complete a project. So obviously we look at scheduling, and most businesses and most things, we want the shortest time to get the whole thing done. But we know that because we have some activities cannot start until other activities are done, so it does change, it makes an impact on the schedule. So we're going to be looking at that. So one activity cannot be completed until the ones immediately preceding it are complete. And remember, dummy activities have a weight of 0. So all that means is when we drop it down there, it doesn't add any time. It just means it's like running parallel. So if this C activity has to be completed along with D before F can start. Okay, so that's like there's going to be some scheduling in there. All right, so we looked at precedence tables, and we can see, and then we've looked at drawing them up, and that's so that we understand what's going on there. So what we say when we call these things float times. So when we were working through a schedule, we can have what we call is we have the earliest starting time for an activity. So that means the earliest it can start is generally, so say the first activity, it'll have the earliest starting time as 0 because there's nothing that we're waiting for. If you look back at that, say that other one, say even if we look along here. So if we look along here, say activity B, it can't start until A is finished. So if you look at it, B is not going to start until we've had 5 minutes, of the A. So we'll say the earliest starting time. So what you'll see, they start putting these boxes, and the first box is what they'll say EST, the earliest starting time, and they'll have it for B, so meaning here. So the earliest starting time for B will be 5 minutes, and you go on, and so on. And we can't see what's leading into C, so we'll like, so say I'm going to add another activity along here. Say that's D, okay? And and I'll just say we're just going to start here, okay? So if I look, we've got 5. So if we went along this way, it would take us, it'll be 8 minutes before we get to the start of D, okay? And then if you look at C, we would get there in 6 minutes. So what that means is when we have a little table here, and we will say, the earliest start time is actually the biggest time, because we can't start D unless B's finished as well. So because there's 8 and 6 minutes are the options, but the earliest it can start has to be the biggest one, the 8. Because you see, I have to have B completed. It leads into D. So D can't start unless B's finished as well. So that's what we will call like the D, the earliest starting time. Okay, so we work through the projects. So you're going to see the network, and we work through and we get all the earliest starting times for each activity, and then we get to the end. And when we get to the end, that end number is going to be the minimum time it takes to do this schedule, okay, or this whole network, okay? So what they'll do is, and if we say we worked backwards, so say then I'm going to add, I'm just going to say D is 3 and we get to the end. So what will happen is we'd get to the end and I'd add that 3 on, and with the 3 minutes to the 8, so we'd say 11. So 11 is going to be the earliest time, like the minimum amount of time I can do to get this whole schedule done, okay? So then what we do is we work backwards. So you start with at the end, and then what we call, so this one was the earliest starting time, this one's the latest starting time. So if you think about it, because say, and you're going to notice it here, because so I'll just call this one, because we called this the start, we're going to say A had a 0 starting time, and we're going to say C had a 0 starting time, okay? So if you think about it, when you're at this little point here, if you are traveling along the C activity, you can actually get to the end, and you could actually, you've got 2 minutes up your sleeve, haven't you? There's 2 minutes of waiting before the next activity goes. So what we call that is float time. So it's like you've got a bit of extra time, and you can see that when you go backwards. So if I go backwards, so I start at 11 and I go backwards, and if I minus 3, that would take me to 8, okay? So the latest starting time there for that activity D is 8. And then if I go backwards from, so I'm saying 8 is the latest starting time. Now, if I go back this way, 8 minus 6 is 2. So you can see there's that 2 minutes I can hold up before I start C. C doesn't have to get going. It's got 2 minutes pause time, hasn't it? Because A and B have to go first. So there's how you can see a float there. Now, if I go back the other way, so I'm at D here and at 8 minutes. Now, if I minus the 3, you can see 5. So it's paused. So if I minus the 3, I'm back at 5. And then if I minus 5, I'm looking at this 5 and I minus that 5, I'm back to 0. Okay? And that makes sense. So the latest starting time for that one is going to be 0, because they're the first one. They have to be completed. They took the longest, so they start off first. So they don't have any float time. So what you see, the two boxes, the first one is the earliest starting time and the second one is the latest starting time. If you're asked to find the float, you do the second box minus the first. So you can see activity C up here has a float time of 2, because there was, see, you do 2 minus 0 is 2, okay? And then what we're going to eventually see is what they'll talk about, and I'll go over it again, but they'll talk about the critical path. And the critical path is the one that has to happen because, you know, if it's the one that's creating the minimum time. So if you go along, the critical path is the way where, see how the numbers are the same, 11, 11, 8 and 8, 5 and 5, and then you're back to 0 to 0. So the critical path for this network for scheduling would have been, we have to go to A, we have B happen, then we go to D. That's the critical path, okay? So it's sort of saying what activities have to go for it to be finished on time. All right. So here's the critical path analysis. So in order for the project to be completed in the shortest time possible, it is important that activities start at the earliest possible time. So that was the EST. So we said the earliest start time, and we had a little go at that. And the way they say you do it is forward scanning. So you can see down here in the blue on our example, sorry, we've done forward scanning. And I suggest that you do the two boxes in a different colour, and a lot of people choose blue for the first one. So blue is our earliest starting time. So you can see down here, we're saying EST, earliest starting time. So let's follow it through. So if you have a look at A, activity A is at the start, so it's 0. Nothing happened before it. It's got to start when it starts, and the same for B. Now, if you follow along A, and we're looking at activity C and D, that can't occur until A has happened. And that's why they're saying the earliest start time for them is the 3, whatever this was, 3 hours or 3 minutes that A took. So that's because of the A, and then off you go. So then if we go along, I'm going to follow along D. Okay, we follow along there. So D took 20 minutes. So D has to happen before G and H happen. So if I've gone along that, so for G to occur, we might say, all right, it takes 23 because it took that. But what we have to be careful of, this one is a little bit, this one's got the works in it. If I go along here, so I've gone along the B value and I'm getting to E. E took, if I just looked at the B value, it took 4 minutes before E, before we're here. But can you see, if I went this way, A to B, that takes 8 minutes. So those two, because C leads into E, we have to wait till C finishes. And that is why this is an 8. Okay, so before E and F can go, they're an 8. So you can see that's where that's happening. And if you come down, if you follow along here, so say G, so I'm 8 here. If I add 1, that would be 9 there. But what they've done is they've come the other way. They were at 23, and then they added that. Well, if G has to happen before J and K, that means I add 23 plus the 3, and that's how I'm getting the 26. So the EST, the blue one, the earliest starting time is the biggest option, that you can find to get there. It has to be, okay? So you're looking for the largest number here. So you look for ways to get there, and you get there. So we've gone, if we go through, don't worry, we won't practice too much on this one because the blue's there. So we get to the end of it. So they've done all the earliest starting times for all those activities. And then what we're going to do is we're going to backtrack, and we're going to backtrack in the red. So if you have a look, I'm here at 46. So get the latest starting time. And what I do, if I went along M, it'd be 46 minus the 5, which would be, let's just say 41. I'll pop that in there. It's good to use pencil, and use pencil now because we're going to change that. Okay, if I went, if I came back to this point via I, so you can see there was another option there by I. So that means I've got to go, I could go this way, 46 minus 3 from down the L going backwards, then that would give 43. And then when I'm here, if I go backwards that way, what's 43 minus 3 would be 40. So when you're doing the latest, the red one, you pick the smallest number. So because it took 40, I'm going to put 40 there, okay? So then if you go backwards, so I'm at 43 in the middle here. If I minus 3 from J, I get 40. If I went along this way, I was at 46, and I minus 11, I get 35 for K. So at this point here, we're going to pick this smallest one, okay, which is 35. And then that's what I do. I go 35, and if I minus that 3, I'm going to end up with, if I go along G, I'm going to end up with 35 minus 3, so 32 there, okay? If I go for the H way, it would have meant I came from 40 minus 17, which is 23. So at this point here, this is going to be our latest starting time. Take the smaller one when you're in the red, and then you keep on going. So if I went 23 minus 7, what would that be, 16? So if I've gone along the E, if I went along the F way, it'd be 35 minus 1, which would be 34, yeah? So if I've gone along this F way, If I go, and then we go back, so remember this 16's the smallest down here at this point. So 16 minus 5, if I go back the C way, would be 11. If I go back via D, it'll be 23 minus 20, which is, oh, sorry, I don't even know, 3. Yep. And then now, so that means this one is our latest starting time for that one. And if you do 3 minus 3, that's 0. But if I went this B way, I would take 16 minus the 4, which is 12. So you can see these ones, some of them have a big float time. So if you look, the ones that have a 0 float time is the critical path. So I'm going to do it in green and I'll show you. See how this one would, 46 minus 46 would be 0. So that's on the critical path. Look for the other ones. Here's another one, 40 and 40, 43 and 43, 23 and 23. Then I had 3 and 3 and 0, 0. So the critical path would have been this way. We would have gone up there, along there, to here, to here, to here. So that's what you call, that's the 0. You're following the ones that have 0 float time. So just maybe to put an example, I'll do down here, let's do this one. The float time for K equals 35 minus 26. So what does that equal? 9 hours? Yeah? So before K starts, it can wait 9 hours and it will not affect the critical path, meaning it will not affect the time of the minimum finishing time. So that's what a float time means. And so you won't get any float times on your critical path, okay? Only on the other ones. So I'm recording. So we're just going to practice here. Boys, can you see here, just to go over the dummy thing, we can see E. E must have C, and C only must be completed. But then when you see C also has to be completed for F, that should indicate to you, that should indicate to you the dummy. All right? So we know there's a dummy and you can see it there. So because E, you can see E comes out of C, because that's what I said, the one by itself will come out, and then you'll see the dummy will be going to F, which it does. So that's just practicing what we did. So they've drawn it up. So let's go through, we're going to do forward tracking. So remember, in the blue is the earliest starting time. And remember, you pick the biggest number. The biggest number for this, okay? So the biggest number to get to that spot. So if you look at A and B, when they're at the start, nothing before them, they're 0. So off I go. All right, if I went along A to C, C must have A happen. So the earliest it can start is 8, because A took 8 minutes. Then if I go along down the bottom, if I go to B, now B leads into D. So I'll call this, put the letters out the front as well. So I'll call this D here. Oh, sorry. Yep. So the earliest it can start is 6. Then you go over here. This one will be F for F. Now, 6 plus 2 is 8 if I came from the D way. But if I go along here, C to E, it gets to 9. Now, if I go down there, that means this could be 9 or this could be 8. So which one am I going to take? 9. Good. So just take the 9 and I'll just rub them out, okay? And that's why that's 9, because of that dummy code. Because C has to finish before F can start as well. All right, and you can see that up there. All right, then we keep going. So if I go down to G, so if I go via the E way, 9 plus 3 would be 11, or I've got 9 plus 1 is 10. Oh, sorry. God, even there. Sorry. 9 plus 3 is 12. Or 9 plus 1 is 10. So which one am I going to take?
12.
Yeah, 12. So I'll just rub those other two out. We're going to leave 12. And then there's no other option, so we keep adding on it. So 12 plus 2 means this one would be 14. So for H is 14. And then 14 plus 1 is 15. All right, so now we've got that. I'm going to go backtrack. So latest starting time. Okay, and that's, you take the smallest option. Okay, and I'm doing it in red. So the end one's always 15, like the same number. So we start with 15. The critical part, the end has to be the end. Okay, then I go backwards. So 15 minus 1 is 14. And that makes sense because H, there's no other option, is there? So that one's got to be that. Then 14 minus 2 is 12. Okay, so now I'm at this, looking at this 12. If I minus 3, I get 9. 12 minus 1, what does that equal? 11. So can you see activity F has a wait time, a float time? It's going to have a float time. Okay, let's look at, now, we're back here at 9. So then 9, I'm up here at E. So 9 minus 1 would be 8. And then over here, what we're going to do, now if we got back, yeah, we're going to do 11 minus 2, which would be 9. So 9 down there. Then 9 minus 6, which would be 3. Okay, so if you do that, and then this one, 8 minus 0, so you can see these ones, oh, sorry, I'll do it in green. These ones are 0, they've got no float time. So the critical path was going along there. Okay, so the critical path was A, B, C, and so on. When you do the critical path, you start at the start. So you go, you can say start if you like, and you go activity A, C, E, G, and H. Okay, so this one is, if you want to, it ends up being the same, but let's have a look. I don't know where we did that.
That's the one we just did.
Yeah, it was the one we just did. That's on your sheet as well, isn't it? Okay, so what we're going to look at here is we're going to practice what we did yesterday. Then we're going to try and find the critical path using the backtracking and that. So here I've got the start, okay, and obviously activity A, and I'm just going to put a 6 there, and activity B also comes out of the start, and it takes 9, so I'll do that. Now, C has to happen with A and B, so I'm going to... yeah, so I'm going to connect these ones. Sorry. I've got to connect it, so I might just bring that. Oh, so this is not going to be good. Why am I not going to do it? I'm not going to be able to connect it. And what should I see? I've got C is A. I need a dummy. So what I'm going to do is I'm going to have, I had this as A. I'm going to have C come out of A. Yeah, and it also has to happen, B also has to occur too. So if I look, is there anything, D also comes out of, and then we can put a dummy. No, but that's parallel. No, you can't do that. Okay, so, so here, A and, oh, wait a minute. All right, so we've got this one. So we've got C, A happens before it, and B happens before it. and then we've got D, we have A and B.
Should the arrow go the other way?
It should go both ways.
Yeah. Yeah, that's what.
No, because that's a parallel. Oh, yeah, you could probably. Let's go, and let's keep going. Yeah, it's probably a double dummy. So let's keep going. So then E comes after D. Oh, sorry, and I should be putting the times in there. So what was D? D was 7, C was 8. And then I've got E, which was 10. And then F comes from C and E. This one we can join. Yeah? And we've got, that's F, and that is 12. And then we get to the end. Okay, so now what we're going to do is we're going to draw our boxes. And so I'll just draw them. So the first here, this is A, and the earliest starting time I'm going to draw in blue would be 0. And then we've also got option B down here, which is 0. Now, if I go to C, C can't happen, well, it can either be 6, or if B has to happen, B's got to be 9 minutes. So what's the earliest starting up time up here? 9. Okay, and then if we look down here, we've got D, and even though A's would only take 6, so the 9 is still the earliest starting time for that. Then you get down to here. Okay, so E, what's 9 plus 7? 16. And then if you look over here for F, now if we were coming along the bottom, it would be the 16 plus 10, which would be 26. Or if I came along the top, 9 plus 8 would be what? Would be, it'd be 17. So which one's bigger? 26. So I'm going to put 26 in there and rub that out. And then we get to the end. So 26 plus 12, which is 38. All right. So now we're going to backtrack in red. So 38 minus 12, 26. 26 minus 10 is 16. I'm just going along this way. Then 16 minus 7 is 9. And then 9 minus 9 is 0. So along the bottom is the critical path. Now, if I'm back up here, I'm going to go 26 minus 8. What would that be? 18. Good. And then 18 minus 6.
Don't you have to add the dummy?
18 minus. Yeah, 6 dummy.
Yeah, I actually think you might have to, because that's a double dummy. You got to make that. What's the latest, the smallest number in the red connected to that? 9? Because you could go. Yeah, no, actually you don't do it that way. Keep it as that. What was 18 minus 6, which is 12. Okay, so when you look at here is the critical path. And what float time does say C have? What's the float time of C? 9, that's right. So this is just going to summary up, and then I'm going to stop it there, I think. So if we look at the critical path is a sequence of edges that makes up the longest path. So the longest time is the critical path. The process of terming the critical path is critical path analysis, which we call the flowing. So we go through on the blue and backtrack on the red.